Prof. Khoshnevis is the founder and CEO of Countercrafting Corporation and is a Dean Professor at the University of Southern California. He has been active in robotics and mechatronics related research and development projects. He has over 100 US and international patents and is a National Academy of Inventors inductee, a member of European Union Academy of Science, and is a fellow member of Society and Manufacturing Engineers, a fellow of Society for Computer Simulation, a fellow of the Institute of Industrial and System Engineering, and a NASA Innovative Advanced Concept NIAC fellow. Because of his countercrafting invention, he received the 2014 grand prize among 1,000 plus globally competing technologies in Create the Future Design Contest, which was organized by NASA. Prof. Khoshnevis' another 3D printing invention, selective separation shaping, won another international competition grand prize by NASA in 2016 as the most capable and versatile metallic and ceramic additive manufacturing technology for microgravity and planetary applications. In 2017, Dr. Khoshnevis was selected by Connected World magazine as one of the top 10 pioneers in the Internet of Things.
Let's welcome Dr. Khoshnevis.
Thank you. Good morning, everyone. I would like to thank Jackie, first of all, for inviting me to participate in this conference, and NUS, of course. 3D printing is very close to my heart. I've been spending about 30 years. I was one of the early guys when not too many people had heard about 3D printing. I was captured by the idea when I saw one of the early crude machines at an exposition, and I just couldn't stop thinking about the possibilities. So my background is manufacturing processes, basically, and robotics and automation. I've been interested in anything that has to do with building stuff. And later on, of course, with the advent of microprocessors and robotics, manufacturing was revolutionized, and therefore I also got into mechatronics and related stuff. And since then, I have been expanding my field a bit, and I've done inventions in many different areas that are related somehow to, my inventions are related to use of mechatronics in developing a lot of different systems, including medical, oil and gas, unrelated necessarily. But the heart of my work is really 3D printing. And in 2017, I received funding finally from a European company to start the Countercrafting Corporation. So the title of this presentation is Past, Present, and Future Prospects. Okay, this is not advancing. Is that on this computer? I can. It's not working. It's down. Okay. Okay. So I've been involved, as I said, in different 3D printing technologies very early on. This is one of the early technologies that I developed called SIS, Selective Inhibition Sintering. Now it's being used by more than 10 companies, have commercial products in polymeric and metallic, more recently ceramic parts. So it was during research in this field when I observed the fact that they're extremely slow. It takes a long time to build even small objects. And my concern was really speeding these processes up. And that's how I came up with the idea of contour crafting. I wasn't thinking about large-scale structure construction. I wasn't thinking about building construction. I just wanted to make 3D printing faster. And then I noticed that there's really no way other than making the layers thicker. But if you make the layers thicker, you lose surface quality, especially in a slant and curved surfaces. You're going to get this staircasing effect, right? So contour crafting was an idea which would allow you to build with thick layers and yet maintain smooth surfaces. My first focus was on some industrial objects, and it took a few years before I thought about construction. So 3D printing builds layer by layer. This is the issue that attracted my attention. And I noticed in 1994 that the only thing that humans have ever built in a layer-wise fashion are actually buildings, right? Bricklaying is a 3D printing method, and we have been doing it for thousands of years. And that's when I developed this conviction that the best use of 3D printing may actually be in construction, which has got a huge economic volume worldwide. It's typically the highest everywhere. In the United States, it's the highest sector of economy, for example. 3D printing builds layer by layer, and we've been building like that, building structures like that for many years. That building is in southern Iran, entirely made out of clay and straw, adobe material, and it's 2,500 years old. 3D printed. Contour crafting is, again, as I said, it's a basic, simple concept. There is a nozzle that has got a large orifice, material comes out of it, and the material is basically smoothed out by a trowel that changes angle on the fly under computer command. And as you see here, the structures that I built have an extremely smooth surface quality. This is a form of clay. In this particular thing, the layers are 6 millimeters, but the surface quality could be like 2 microns. This was unprecedented, and it still is unprecedented. No 3D printing can actually make surfaces as smooth as contour crafting when you use it at a smaller scale. At the early days, I created a number of specimens to just show the potential of the process with different computer models. Showed that all kinds of curvatures are possible, even sharp corners you can make, and then hybrid processing of multiple materials would be possible. This is basically a gypsum-based material, and inside is another construction material. And then later on, I developed different scales of the machine, and this has taken, of course, a lot of effort. Students ask me, well, you're lucky, you stumbled on a good idea, and you managed to do all of this. And I tell them I spent 3,000 hours writing proposals. That's the reality of it. 3,000 hours almost writing proposals to get money. It wasn't easy, right? At the beginning, nobody believed in it, right? And it's been a long journey, with a lot of effort behind it. I'm telling this for the younger groups. Things don't happen easily. You have to be at it. You have to first believe in it yourself and dedicate yourself to it. okay, when there are a lot of non-believers around. Just talking to a student here who's after what is the next big thing, I want to get into that, right? Oh, blockchain is a big thing. Let's get into that. No, you should create the big thing yourself. Somebody created blockchain. Somebody created internet, right? But doing that takes effort. It takes passion. It takes vision and a lot of dedication. Anyways, yeah, as you see, this nozzle can build hybrid balls at the same time, 3 different extrusions. These things were done in 2006. Still the most advanced nozzles that have ever been seen, at least by myself, anywhere around the world. That was the first large-scale machine that we built. And these are some of the implementations that you see. We built a lot of different specimens with different materials, different structures. But I never attempted to build a building and demonstrate it as a viable building, because I have to get there first. And I don't think anybody has really got there that much. But I respect all the effort that has been going on, and I welcome all of them. So, along with the concept of 3D printing, I also entertained the idea of embedding other objects inside the structure, and including reinforcement and plumbing, even electrical network. To me, buildings are much simpler structures than a lot of other things that we manufacture, like cars, right? Cars are extremely complex. They're made out of thousands of parts. Precision is much higher than buildings. And yet, the entire thing is almost done automatically these days for certain cars, right? Buildings are relatively simple. The only difference really is that they are not mobile. They don't use standard material that we use in manufacturing. They use special, cheaper materials in high volume, and they're large. These are the 3 distinctions of buildings. Okay, so later on we did a lot of other studies, incorporation of steel fiber into the system, continuous coil embedding, sensor embedding using conductive concrete. One of my students brought this to my attention last year. This chart is published by a firm in Netherlands. It was published in 2016, I think. But as you see, today a number of activities are going on around the world with respect to large-scale 3D printing, and they have registered me here. As you see, long before anybody started this, my mind was after this dream. And again, I'm very happy to see all this activity around the world, and I'm really also anxious to make sure that this actually gets somewhere while I'm still around to get to see it, right? Things don't move that fast in technology development. If you read about it, you'll notice some of the technology. Jet engine took about 40 years since its inception, since its invention, till it actually flew by commercial airliners. When Graham Bell invented telephone, it looked like a slam dunk at the time of telegraph. But the president of Western Union back then made a famous statement Said when people have telegraph, who needs telephone? And he was very right. He was a very smart businessman. Because we are talking about the time when there was no wiring. Even electrical wires were not in buildings. People were using kerosene to lighten up their houses. So the infrastructure was not there. Similar things are true about automated construction, whether it's 3D printing or robotic constructions. It's not just building something. There's a lot of other things that go with it. Right now, in the course of construction in the United States, like 10, 12 times, the inspector from the city comes and looks at it. Sometimes you have to wait a couple of weeks for them to come. Doesn't make sense to have the speed of building a building in 24 hours and you have to wait several weeks for inspectors to come and look at different aspects of it. When you think about the complexity of inspection and regulatory requirements, then you understand that we have a long way to go. Okay, so at present, of course, there is a shortage of 800 million houses worldwide, according to United Nations statistics. Global markets are grossly underserved. Nearly 2 billion people are homeless and living in slums. Annually, about 40 million people lose their houses due to war and natural disasters. Just look at all the refugees of Iraq and Syria right now, what's going on in the world. So many millions of them need houses around the places where they have taken refuge. Shortage of commercial and industrial buildings also is there. So the demand is there, of course. And there are many reasons why construction needs to change. As I told you, it's the biggest sector of almost every economy. Labor efficiency is low, skilled workforce is vanishing. Every country usually that I go, I notice that the construction workers are coming from adjacent poorer countries. People in that country are not willing to work there in construction field. I was in Malaysia and the worker come from Indonesia, for example. I went to Iran, construction workers are from Afghanistan. Iranians don't want to do it anymore. In the United States, all Mexicans, right? Control of construction site is difficult. I saw somewhere they were building an apartment complex. There were 400 apartments in there, and there were only 2 supervisors. And yet the building was being built. You know, it would close, drywall, patching, everything. A lot of it is uncontrolled. People don't know exactly how they were made, whether it was according to code or not. And we are at the time when, in manufacturing, we are doing 3 Sigma quality control. It's just a big divide between the 2 industries with respect to quality control. So construction causes a lot of accidents, of course. 60,000 fatalities every year globally. That's a lot. In the United States, it's like 6,000 fatalities, 400,000 injuries, a lot of them spinal cord and whatever. Waste and trims are high, low-income housing, emergency shelters are critical, and all other products, of course, are fabricated almost automatically today, except buildings, right? Just look around yourself. This thing has been made automatically. This one, my shoes, clothes, a lot of these things are done automatically. Nobody builds things by hand anymore, except these buildings. So there are reasons that it has to be automated. As I said, the homelessness disaster, natural disaster is on the rise because of global warming and all, and the refugee situation. The company that I created has, of course, building construction as one of its main goals, but we have not limited ourselves to it because of all the reasons that I gave you. We're going to try our best, and our vision, of course, goes to all kinds of buildings. But there are barriers against implementation, as I told you. Construction is a conservative industry. Over the years, when I started this, there was a lot of excitement. A lot of people have sent me emails, thousands of emails, a lot of telephone calls, a lot of visits by construction companies. Not a single one was willing to put a little bit of money for R&D. So if they want somebody else to pay for it, when it is ready, we are going to use it. Then that's understandable. They're not in the business of supporting R&D. They have typically a short planning horizon. They want to be quick in making profit from their investment. A low profit margin, right? Construction has got a low profit margin. There's a lot of competition in it. And there are a lot of regulatory barriers. As I told you, inspection is an issue. In certain areas, of course, there is labor union. In certain areas, United States, if you make something, for instance, that allows the painter to reach higher, they're not going to allow you to sell that brush that has got a longer handle, for example. Because it improves their productivity and it's not good for the laborers. It could be that bad. Another important issue is that when we talk about 3D printing a building, we're not talking about really building a building. We're talking about building a shell of it, primarily the walls of it, right? Well, those of you who are in construction know what percentage of the cost of a building that is. It's not the biggest part of it, right? Actually, it's a small proportion of the overall cost. There's a lot more that goes into a building. So when we talk about building construction, we have to know what it is that we're talking about. That's why I thought about integrating other activities like plumbing, electrical, and others in the building construction. So what is the future? Our focus in the company is also on infrastructure. So large structures are not only buildings. For example, one area is tower construction. The company Siemens that gave us a feasibility study contract to look at the possibility of building towers for wind turbine. You know, they build over 1,000 towers every year for wind turbine. There are other companies that are even bigger. They build 2,000 per year. So it's a hot market. And so we developed a concept for tower construction, automated tower construction. The tower is the most expensive part of a wind turbine establishment. For like a 1 to 2 megawatt turbine, it's like $1.2, $1.5 million. Over $500,000 is for the tower. $150,000 almost for the foundation. The rest is for the generators and the blades and the transformers. So the tower thing is important. Of course, if you can build towers, you can build chimneys, you can build water towers, I don't know, silos for agriculture. That's a different direction with potential. And regulations are probably less stringent. You're not building in the middle of the place where people live. There could be in isolated areas. Yeah, pylons for like, this is a Hyperloop, Elon Musk's idea. A couple of companies approached us for building these pylons for them using this technology. Okay. I'm fascinated with the idea of space, of course, because I think future of humanity is in space. A lot of people don't take space technology seriously. A lot of people consider it a waste of taxpayers' money to put money in space research while they're using a cell phone to talk to the other part of the world, unaware that they're using satellites that are space technology. They're driving around, they're using GPS, that is a space technology. They use the weather forecasting, space technology. I mean, so many things that are happening that are space technology. All these television programs we receive on satellites, they're space technology. There was a vision that made this possible. At the time that vision was introduced, a lot of people thought it was outrageous, crazy. But now we see that they're happening. So I'm telling you that in the future, not distant future, there will be more manufacturing done in space than on Earth. You have abundant source of energy, our solar system, or our sun, and you have abundance of material, planetary material and asteroid materials. As you see here, this is the asteroid belt. These are rocky bodies that could have a lot of different useful material, including precious metals, with which you can build everything you want. Of course, a lot of ice as well that you can take as source of fuel for rockets. Hydrogen and oxygen are basic fuel for rockets. And in the future, we're going to capitalize on the resources that the asteroid belt offers, the energy of the sun, and the design is the only thing that you need, right, in order to build the stuff, and we can beam those from Earth. And then the revolution that's going to take place, that's going to make that happen, is self-replicating factories that will keep on building themselves out of those materials, and therefore your manufacturing capability is going to be exponentially increasing in a very short while. And of course, they go through evolution as well. As we learn more and more, the design is going to change. It's an equivalent of biological evolution. It's going to be a robotic evolution in space. Our future is extended through robotics. We don't have to be everywhere ourselves. Of course, there are two directions: trying to create habitation, create, for example, atmosphere on Mars, but they're also changing humans too, genetically, to be able to live in those conditions. So when we think about the future of humanity, we really have to be open-minded about it, because there's going to be a lot of things that are going to be radically different than what it is right now. Understand the fact that, for example, we are bionic people compared to people who lived 100 years ago. We are vaccinated against many, many diseases that would immediately kill them or paralyze them if they were around right now without these protections that we have. So we are not the same breed of humans. In the future, the difference is going to be even more stark. Okay, there are companies now that have been funded to take the asteroid material and build, for example, a spaceship with it. Okay, this is the SSS technology that I developed in the course of a NASA project. This thing allows you to build these metallic parts without layering, without powder layering. Therefore, it can be used in microgravity, zero gravity, because you cannot do layering of material in that kind of condition where gravity does not exist. So these are some bronze and stainless steel parts. They're primitive parts, but they show the potential of what can be done. So 3D printing in space has a lot of potential. I'm going to go over this quickly, but there are a number of companies that are working on mining, not only on Moon and Mars, but also on asteroids. These companies are funded again. Remember, this is not a fanciful idea. People have put their money on it. So this was a project that was funded by NASA for building on Moon and Mars using contour crafting. This is a proposal I wrote to them, and it was a very competitive program. About 800 proposals were submitted, mostly by NASA researchers, and they selected 30 of them, and mine was included. And then we went to phase 2. Among those 30, they chose 9. I was included again, and the last one that was received for the 3rd phase was our project. So the idea is to take the material there and convert it to structures that are buildable without water, without hydraulic concrete. And so this is some of the demonstrations of Martian material. These are Martian material that have been processed using whatever is on Mars without taking any material and without water. We have built this structure, these structures. This is a thermal process. It's a sulfur-based binding. So you can build hangars for landers, for example, shade walls, radiation protection walls. In the case of lunar situation, the idea was you just take the lunar soil and melt it, much like volcanic lava, because the temperature under sunlight on the moon is too high. It melts sulfur. For Mars, it's excellent, but for the lunar situation, you cannot do that. So here is melting of the material with microwave, which is powered by solar panels. And as it was said, received the grand prize, the idea. Next, it was the landing pad. Landing pad is one of the most needed structures, infrastructures for the future of human expeditions. On other planets, right now they all land on soft soils. So this is another version of this SSS for cementitious and ceramic parts that we have developed. As you see, this is the only powder-based large-scale technology. You haven't heard much about it yet, but you will as we make some very large-scale demonstrations. So this layer here is about 1 inch, and it's powder. As you see, it's very smooth, 2.5 centimeters. This is lunar soil, and is converted to ceramic, high-temperature ceramic. These are interlocking tiles. Landing pad must be made out of interlocking tiles, because if you make it out of one monolithic piece, because of temperature differentials of exhaust plume of the lander, you're going to get a lot of cracks and shattered lander. So these have to be basically 3D printed in place, and that's what we're doing. Other ideas that have been proposed is a factory that uses molds to make these, and then a robotic system to bring and assemble them. But what we proposed was basically build them in place using a simple rover. Right now that lander that was shown, this is how the situation is today. The landers land and the exhaust plume pushes the dust away. If the bedrock is not horizontal, if it is a slant, the lander could flip over and you lose billions of dollars of the project. Yeah, so this is the idea, to build landing pads just out of in situ material. So what you see here is basically a nozzle that extrudes magnesium oxide, a very high temperature ceramic, which is abundant both on Moon and Mars. It is much higher temperature than the local soil, and therefore the heater, this is a microwave magnetron heater that centers these, just fuses them under heat. These tiles turn into solid while the magnesium oxide stays powder. Therefore, these things stay locked in place. No molding, no robotic assembly. Yeah, so this was again selected as the best approach among a lot of other ideas. I'm showing this because of future potential of 3D printing. It is not only on Earth, it's going to be also very effective in space applications. So the other research directions, of course, process innovation and improvement, different ways of making it, different robotics structures. At the company, we are trying some very radical ideas. Material choices, we should be more open-minded about the choice of materials. Given that it's an automated process, people need not be around. Maybe we can do things with super high temperature, maybe with some chemicals that are not good for people to be around. Now that we are doing automatically, maybe it's okay. Impact on BIM and BIM integration, that's another direction that has to be taken into account. IoT, I can later on, if anybody's interested, I can elaborate on the BIM part. IoT, Internet of Things, there's a lot of roles for incorporation of that. As I said, in 2017, a company called Doka, I hadn't heard about them, in Austria, showed interest. At that time, of course, there were a lot of other people who wanted to invest, but I chose this company because it's very relevant. They make very high performance, high-tech formwork, self-rising formwork, and some of the biggest buildings in the world, actually the biggest, tallest building in the world is made with their formwork, Burj Khalifa in Dubai. And so they realized that if 3D printing really becomes successful, there wouldn't be need for formwork. So they didn't want to make the mistake that Kodak made in not going after digital photography. They didn't believe it's ever going to take over. So this is a smart company. They're number one in their field. They're multinational. So I consider myself fortunate that we have a relationship with them. And in May of 2017, almost a year ago, we leased this building in near the LAX airport in Los Angeles. It's about 35,000 square feet, 3,500 square meter. And this most likely is going to be our R&D facility. Well, thank you for paying attention, and good luck to everyone.
Thank you, Dr. Khoshnevis.
experience, it is a big difference between cost of printing and the 3D and labor. Specific percentage difference between them, which is cheaper and the most expensive one.
So that's a very good question. You know, the challenge right now, why is that 3D printing is not commonplace? Of course, technologies are not quite yet ready, but even if we can build what we promise we can do, I think economic justification is going to be a challenge. Okay? Right now there is excitement about this, but we shouldn't take that for granted. After a few years, that wears out. And bottom line, you have to show economic superiority over alternative techniques, right? For example, I challenged the gentlemen who were doing this toilet thing. I admire the effort, and I wish them success. But just think about it, how do you compare using molds, plastic or wooden molds, to quickly build these toilets with the option of taking a machine which needs electricity in a village of India and putting these together at an economically competitive price, right? It's a challenge. Again, I say I wish them luck, but it takes a lot of thinking and more effort. Just demonstrating that you can build a toilet is not enough. You have to go beyond that and make it economically attractive. So I was just talking to Professor Jackie. He is a cost engineer, and I encouraged him to really focus on economic comparison. And what does it take for these technologies to get on their feet and actually enter the market? Yeah, that's
Yes,
a critical
certainly.
question.
I think the cost is the main item for constructions. So today, the conference is on construction 3D. Can you raise our hand? Anybody from construction industry here in the audience? Okay, I think not too many. Not too many. I think certainly the topic is very interesting because of multidisciplinary nature. I think cost is a main concern for constructions.
Right.
Well, I'm a structural engineer. I'm from the Department of Civil Engineering. I'm a professional engineer building buildings. We are towards the building of buildings in the factories, manufacturing in the factory, try to stack it up.
Right.
Singapore achieved a landmark. We built 40-story building.
Yes, I am
And
familiar with
stacking
that.
up. So I think 3D printing does bring this excitement to us. We hope that we can print 40-story buildings. But again, cost is the main concern unless you change the materials. Well, I'm facilitating these forums. Any questions from our audience?
Question on the confidence of customers in the type of product. I understand the product is still at the very early stage product. Then you talk about safety, you talk about so many other elements. I mean, there is an element that nobody talked about, which is how could we get into getting the customer trusting the product, the quality of it, basically.
Exactly. So, well, of course, I have no experience. I cannot tell you what my experience has been in people accepting. I can just tell you there is a lot of excitement. And of course, there are a lot of people who hear about the advantages of this and they want it. They say, oh, I have a lot. I keep hearing this from different people. Oh, I have a lot here that I'm about to build, but I want to wait till you do it because it looks like it's going to be much cheaper, right? So what I hear most is the cost. If you can make it cheaper, it looks like people are going to accept it. Of course, if it collapses and kills a few people, that's going to make an impact. But so far, luckily, it hasn't happened. But it's because there are really none that people live in. So I think safety and cost would be the main thing, the main issue. If you can make it attractive cost-wise, you're going to get customer acceptance. This is based on my statistics.
Okay, I think the point well taken. Every product used in the building has to be certified for safety reasons.
Right.
It make it rather difficult for us to implement, okay, unless we certify it. Any other questions from the floor? Yes?
You've shown some samples of things you built in space and land. Were you successful in trying any 3D printing in water or floating on water?
Well, we really haven't tried it, but it shouldn't be a big challenge. You know, of course, there is concrete that is made for curing inside water, but any concrete cures inside water. And we have actually problem with it. Our settling tanks, when we do experiment and we wash our equipment, we have a settling tank, like 3-4 stage settling tank. Concrete sits at the bottom of this, and after like 2-3 days, it hardens. And we have to take hammer and whatever, break it into pieces to take it out. So even regular concrete cures inside water. But there are special concrete that are made for application for underwater.
Right.
Yeah, as long as you make your machine water hardened, that can work in the environment of water, which is not too difficult, then you can do it. We have had a couple of requests for demonstration on that, but again, we cannot do too many things. They say a dog that chases too many rabbits ends up catching no rabbit.
Okay. Well, they can build concrete without water. Okay, you can see the presentations. I'm quite sure we can print concrete under the water. It's just that we need to seek funding. Funding, please approach Jackie, and we'll try to make the technology works. Yes, last questions because of time.
You mentioned that you're focusing on infrastructure projects rather than residential projects because you see a greater potential there. Don't you feel that there will be a greater regulatory push towards safer structures in terms of earthquake resistance and low carrying capacity, especially for wind towers and stuff like that? So is there a greater schism in terms of achieving infrastructure projects rather than residential structures?
Okay, well, I didn't quite hear everything you said, but first of all, I didn't say that we are giving priority to infrastructure. I said that's one area that we are also focusing on. We are not putting all of our eggs into the building construction aspect. And what you said about the infrastructure?
I mean, you'll have a lot of problems with respect to regulations, earthquake resistance, and
Yeah.
dynamic load carrying capacity,
Right.
especially on pylons and wind towers.
Right.
Won't that be a bigger problem than the economics of residential regulation of?
Based on what I have heard from specialists, no, it's not a bigger problem. There are less restrictions on things that you build in areas where people are not around. Of
Okay,
course,
I'm
whatever
quite
you
sure,
build should not
yeah.
collapse, should meet its purpose.
Okay, these are the questions for structural engineers. How to resist earthquake, whether we can print concrete together with steel reinforcement, make it earthquake resistant. These are the questions you should ask. I think there are more presentations coming up. I think we have more opportunity in this conference this 2 days for us to discuss in detail. I can even discuss it during the tea breaks or lunchtime. Okay? So because of time, I need to close this forum so that I can let Jackie to present. Thanks, Professor
Thank you.
Khoshnevis for his brilliant presentation. Thank you very much.
Now may I invite the Prof. Liu to present a certificate of appreciation to Dr. Khoshnevis. Dr. Khoshnevis, please on stage.